Hi guys, I hope you're good since last video. How is your learning going? Why are you learning Rust 4? As I told you at the beginning of this playlist, I learned Rust to be able to make my Python code more efficient, as now there are some libraries that permits to write in Rust and use in Python, and vice versa. It provides also the chance to be introduced to lower level languages with more memory safety. Share in the comment section why you are learning Rust 4. It might be because Rust is just interesting language and fun somehow. Have a break, have a rest. In this video, I'm going to focus on Rust thread. What is that? Why do we need those? Why would I use those as I feel like that I know enough to start coding? The first part will be explaining and answering those questions. So explaining threats, what are threats, and answering some of those questions. Also the question that I had while learning about Rust threats. In the second part, we will be going into the hands-on with very easy examples and use the concept of generic type with it. That's the concept that we've seen in the previous video. Please like and subscribe. Thank you for your support again. Okay, let's get started. Threats. So let's start answering this question first. What are Rust threats? A threat in Rust is similar to an interface in other languages. It defines a set of behaviors that can be shared across different types. A threat provides method signatures, the function name and parameter types, but not the actual implementation. It's like saying any store that wants to provide a customer service must be able to handle these actions. So think of a threat as a contract that types can sign. They define what methods the type must implement, but the actual behavior is defined in the implementation of the threat for each specific type. So this last paragraph here, that's what we are going to precise more. Going through this example of a big tower in Shibuya 109 Fashion Tower, and we're going to be writing some code around it just to explain it. So you imagine Shibuya 109 has different stores, and customers want to interact with these stores in a standard way. So first point, defining a threat store. We'll create a threat named store that defines the standard behavior for all stores in Shibuya 109. A method signature is provided, but the implementation is left to each store. So here we have a threat. Threat is defined like that, threat store. The method signature, serve customer, must be implemented by every store. And here we just got the signature of it. So we could also have here an arrow to say what is returning. So this is part also of the signature. And here is going to take the type, the reference of the type itself, and the extra parameter, which is the reference of the customer name. And here you can also define default method. That is the same for every store. So at this time, when you define a default method that returns something like that, a string, just the opening hours, for example, at this time, you can define what is inside the function. Otherwise, you don't define what is inside the function. You just define the method signature. So here we're going to be saying that serve customer, this one here. This method is a method signature. It defines that every store must implement how they serve a customer, but doesn't provide the logic. While opening hours, this one here, this is a default method that provides the same behavior for every store, regardless of its fields. Another point, defining specific stores. So let's define two different stores. We're going to use the structs here and use the trait. So those structs, so fashion boutique and the sneaker store. We just put the name in. That's the name, maybe the name of the salesperson in each store. Implement store trait for fashion boutique. So we use implement, impl, store for fashion boutique. And here we're going to take this function coming from the trait. So because here it's defined in the store trait, we got the signature, and the logic inside will be specific to fashion boutique. And here we're just going to print self-name, the name of the salesperson is helping the customer name, and here it's going to be printed with this formatting. The same way, for sneaker store, we're going to be implementing store for sneaker store. The same method, we use the signature of it, same signature as in the trait, and after inside here is going to be specific to that store. The salesperson is going to be different name here. It could be some other different fields, but here we just make it simple for this introduction example. So each store implements the store trait, defining their own logic for how they serve customers. The serve customer method has a signature, which is the signature here defined in the trait, so defined in the store trait, but the actual behavior depends on the specific store. So the internal logic of the function will be defined at the implementation level. Using traits in action. So how would we use it in our main function? Just before compiling, how would we call those? Here is an example in how we're going to be instantiating those structs. So those structs they define with a name. So boutique is of type fashion boutique, so we have the name. Here instead of a salesperson, we put the name of the store. Same here, sneaker store. We use here 109 sneaker store. So you can use it in different ways. So using trait method on the different store. Here boutique, serve customer, Alice serve customer, Bob for sneaker store. So they both here using the implemented methods that we've seen just before. And after recalling that function, there are another function called opening hours. So opening hours is going to be the default function that you have defined on the trait. Just going to print here what is coming next so you can see it here. So the trait store, serve customer, but there are another method which is a default method that can be used straight away like that, because it's just printing the opening hours. They're all in the same building, 109 Shibuya, so this time they're all closing at the same time. So Alice is helped by Shibuya Fashion and Bob is helped by 109 Sneakers. So here we could have put maybe the name of the salesperson, but we put just the name of the stores. And those ones here, they're going to be using this method here, which we have implemented to fashion boutique and sneaker store. And in the logic, it has to return that the customer has been helped by the salesperson or the store. So both stores share the same default opening hours method, provided by the stored trait. So this one is shown by both also. And after here, that's just a reminder so you can see how it looks like, because it was a few slides away. And here we get the example on the side. You can pause the video here just to check the details. Key points, just a little recap. We're in the middle of the explanation. We're almost there before going to the hands-on, but let's recap a bit. Trait. Define shared behavior in the form of method signatures. Threads do not store data and not access fields directly. So it's just a signature. They only define what behavior should be provided. Talking about that signature, the method name, parameter, and return type also, you can put, are defined in the thread. This is the contract that types must fulfill. When we say types here, it's for example structs. It's a custom type. When we implement it, it has to follow that contract, that signature function. For example, function serve customer, this signature defines the method signature that any type implementing the stored trait must provide. So if any custom type want to implement the stored trait, so the stored trait at this time, it must follow this signature to serve customer, for example, for the stores. Implementation blocks. So that's inside when the implementer provides the specific behavior for each type that implements the trait. So the implementation block allows a specific struct, example fashion boutique or sneaker store, to define how the method works and access these fields. So that's where you put the function logic inside. It has just to follow the parameters that are taken by the function and the returned values from the signature. Default method, so that's the other method that I showed you. Default method in thread. Those ones, threads, can also include default methods implementations. These methods are field agnostic and do not depend on the struct specific fields, because those ones, like the function for the opening hours that we had, string has the same implementation for all stores. So here you see there's no parameter passed, we just use the struct and we return the string. So any store having the same opening hours can implement this one and just use it. So why trait and implementation blocks together? So that's the question I had. Just telling to myself, I could just use implementation then. So thread provides a central interface, example, how each store serves the customer. Implementation blocks connect the interface to concrete data and provide the specific implementation for each type, including access to fields, name, for example. So the thread itself can't access to those fields, can't store any data, can just define signature, while the implementation, we need it because this is going to be accessing to the fields, and if it is a state type, for example, at this time it will be able to update those. Why threads are useful beyond the need for implementation. Okay, now I understand why we would need threads instead of using implementation everywhere. But let's go a bit more into the details here. That's the last part of the explanation part. So first, enforcing a standard interface. Threads help enforce consistency across multiple types. In Rust, type safety is a priority, and threads are like contracts that ensure each type behaves as expected. So if you have multiple structs that need to behave similarly, different stores all need to serve a customer, a thread ensures that all those structs implement the same set of methods. Without threads, every struct could have a method called serve customer, as I said before. But here it's important, the compiler wouldn't enforce it, leading to potential inconsistency of errors in a large code base. So it helps also to not get those errors. Let's say you have in your code base 10,000 structs. You don't want to implement for serve customer doing individually. You want to enforce these parameters passed to it and what it returns. And threat here is very helpful. Polymorphism. Try to enable polymorphism in Rust, which means you can write generic functions that operates on any type implementing a particular trait. So that's what is powerful here, what we've seen in the previous video. Using generics, you can pass in a function any type, custom type or normal types. And here you can combine it with traits. So those implementation will be even more flexible. For instance, if you have a function that needs to serve a customer, instead of writing it separately for every store, you can write a generic function. Here we provide an example. Store, serve any store, which has the T, the type, and the type, the generic type here will be of type of the trait, store, which is passed here as a reference of a store, and we have the customer name as a reference to the customer name. And after here, because we have the type store, we can use the signature function serve customer and pass in the customer name, which is an ampersand string as defined in the store trait. So this is following the signature. Here, serve any store works for any store that implements the store trait. No need to rewrite the function logic for every new type of store. Code reuse. So that's another point, an abstraction. So this it's the consequence of it. Traits are a way to enable code reuse and decouple implementations from definitions. Imagine you have several different types that can all perform a common action, like serve customer. Instead of repeating the logic, threats provide a common interface, while the implementation block allow the specifics of each type to be implemented once in the most efficient way for the type. So here you understand that you can get this code reuse abstraction away, abstracted away, and that you can use straight. You can implement those and follow this the signature. So without traits, you would need to duplicate function signatures and handle them differently across various structs, leading to a more error-prone and less maintainable code base. So we have our little code bases using 1 or 2 files, but just think at a huge code base having 100,000 lines of codes. So at this time you need to have those threads implemented. For small code base, you can play with structs and implementation doing separately, not use thread. But when the code base starts to be big, so you want your code to be scalable. So even if you write not many lines of codes, it's good to have this logic and understand that your code can grow in an easier way if you implement threat. So default methods are useful, but not the only purpose. So the default side, that's the function in which in the threat you can be defining the logic of the function, what is inside. So yes, default methods are great for centralizing common behavior, especially when the method is field agnostic, printing a value or a fixed message. So that's what we used for. Otherwise, however, the real power of threats lies in their ability to provide a consistent interface and abstract away differences between various types. So REST, being a statically typed language, uses threads to enforce this behavior at compile time. So this is a REST way of doing it. In Python, you can do use those interfaces, but in Rust, it's a typed language, so it's very important to check those types at compile time, and threads helps you to do that in an easy way. Example, how threads solve problems in larger systems. So we talked about large code base. So let's just have this example. Imagine you are building a system for Shibuya 109 that involves multiple actors, stores, customers, and services. Example, delivery or product exchanges or something more complex. Using threads allows you to do the following. Define a thread for all entities that need to provide customer service, for example, and you implement the thread for stores, delivery services, and customer support or any other service. So with generic functions or algorithms that can interact with any entity providing customer service without caring whether it is a store, delivery, or support center. So here, that's where you can also use the generic types, which can help you. Okay, we are done with this explanation part. Let's have a break. Please like and subscribe. Okay. Let's create a new file. Let's call it thread Shibuya 109.rs. So here we are going to create a method shared across all business. So across all businesses, and returns a service description. Okay, so let's create here a thread, which is going to be the service. So let's create the signature method. So we create our function, just the signature. We don't put the logic inside it. It's going to be called provide service, taking the reference of a struct, so ampersand self, and returning a string. So we can say our code that's going to be our code structure. There will be a thread, the thread we have created already. After that, you have the struct. After the struct, we have the implementation. So any function just to implement it to the struct. And that's where we will be able to use this thread signature if you want to create a business logic in it. After, we're going to be doing an instantiation through a variable of this struct. And after, we're going to get our terminal output. So we're going to use the thread, the signature function, implemented on struct. So that's a simplified way to see the workflow, because it can be a bit confusing of what you should create and when. But that will be the kind of waterfall. Normal method and signature in the implementation here. There are any method that you want to do, plus if you want to put this signature method to use the thread. And that's how you can have several structs implementing the same thread. That's where the advantage is. We're going to be scaling up this example. So we're going to start slow like that. And after we're going to be implementing some concepts that we've seen in the previous videos and some other ones that we haven't seen yet. We're going now to create a struct for different businesses. So the file is called thread Shibuya 109. Shibuya 109 is a tower, like a commercial center where you can buy stuff. So here we're going to create a struct for the business karaoke, having a field service. I'm going to use here the decorator derive debug straight away, so we don't need to implement display. Just to not overcomplicate the code. But whenever you create something custom, you need to implement everything. So here we're going to use this decorator. The second business is a manga kisa, and the third business is a store. So we have 3 structs having each a service field, which is a string. Now let's implement the specific logic from the, let's write it here, from the signature thread. So we have our thread, we have created it, it's called services. It has one function in it, just the signature of the function, name of the function, parameters, return type. You can omit the return type if you want. Implement service, so we implement the thread for karaoke. So we're going to be implementing this thread for every single business, the karaoke, the manga kisa, and the store. So here we're going to use the same signature. Function provides service, %self, which is the structure, so karaoke, and the string, which is the return type. And now inside we can put a custom business logic specific to this business, karaoke. Let's provide, so we're going to create a variable, provide room service. I'm using here format to just get a string formatted. Okay, we're going to put a message is available for private karaoke rooms. And here we want put the service, self-service. So the struct karaoke dot service, the field service, which is going to be defined later on when we're going to instantiate it. And after we return this sentence. I'm just going to copy it, modify it a bit to adapt it to every single business. Here it's manga kisa, we still have the service. We just need to change the sentence, maybe the parameter name, the variable name. Just provide the room service. So here is available for VIP client for free. It's another sentence. Let's change this for VIP client service. And we're gonna return VIP client service. Okay, so we good here. Just need to maybe change this. Put the comma. And now we're going to be doing the store. So here is store. That's the last business of the tower. 109. Extra service. So we're going to call it. And for the sentence, is available for people sending more than 5,000 yen. Spending more than 5,000 yen. In the store, we're going to do a kind of a delivery service or something like that. Extra service. Now we're going to create a public function. That's the one that we are going to import in main.rs and print. Thread required for 109 Shibuya Tower. That's the name of the function. You can put a shorter name. Let's instantiate variables for each struct. So for each business. And now here we're going to instantiate those structs. They all have a field service. And we're going to be creating the string, which is going to be representing that field. So let karaoke instantiate the struct karaoke. Inside the struct, there is a field service. We use a string from to create that service message. So I need semicolon after the curly brace, and here a comma. So the sentence, that's karaoke. So let's create a special mic, golden mic, Dolby surround, galactic. So that's a special service. The special mic is available for karaoke, and I'm just going to copy it here and change for another business, which here is manga Kisa 109. We're going to instantiate the manga Kisa business struct, and we're going to just change the service sentence. So here, udon and tempura food. So that's another service, catering service. Here we go for the last business, which is a store. It's called Junko Store 109 Store Instantiation, and we're gonna change the message. Home delivery service. Okay. We can optionally, you can also print it. So this one is karaoke, it's not manga kissa 109. And karaoke 109. I need to copy this, and I'm just gonna do the same for the other variables. We just need to change the names with the N, and here same, manga kissa 109. And here we're gonna paste the last one. So here was the instantiation. So those structs now, they have this service variable field with a value. Okay. And we're gonna add to the logic now. Now we can use the method. So we have implemented different methods. Implementing the trait signature. We have inside the implementation for each struct, this service trait signature, we have put the specific business logic. So this is illustrating what we've been explaining in the first part of the video, which was the explanation part. You got your signature in the trait. And what is useful here is that those signatures can be used by some other structs. And all the types are checked at compile time, which is very useful. And here we're just going to do a karaoke underscore 109 provide service. We're going to do the same for the other ones. And here we have store 109, Junko store. Okay. I'm going to close the comments. Let's check for the comments to close. Implementations. I've seen some comments here. Okay. So we have trait that you have created, structs, we have implemented the signatures, we have instantiated those ones, we're using the signature, and now we want to get the terminal output. Service, that's the trait, this is the signature. Okay, and those structs. Okay, each struct here has a service field, which is a string. we have implemented the thread service to the structs. So this thread here has been implemented for karaoke for each Mangakisa store. Just a little recap, really quick. We have the function signature here, service, function signature, we put in the variable and we create the specific logic for each struct implementation of this function signature from the thread. We're going to instantiate here the struct as usual with a message. There is only one field, service, keep it simple. And after that here, we're going to call this implementation on the struct. Okay, provide service. I think we're good. Let's go to the, wait. I just need to copy the function name. It's a long function name. Thread Shibuya 109, that's the module. Let's go down here. Just gonna do it again here. Okay, mod thread Shibuya 109. Thread Shibuya 109 and the function. Okay, thread required for 109 Shibuya. So this example I've done it before. It should work. Unless I've done any typos. Okay, there are some double quotes here where they shouldn't be. What else do we have? Let's go at the top. Missing provide service implementation. Why is that? Just because of those double quotes. So let's find those double quotes. Where are they? Here. Especially that I use copy and paste. So we will get this error repeated in several lines. Okay, this is done. There is more, but we're just going to clear it step by step. The next one, let's go at the top. Function. There is an associated function with similar name. So here there might be a typo in the name. You see here, provide services. This is called provis services. So this is not going to work. Same. Here we have provide services. It's fine. And here we got provis services. Let's change this typo. So copy and paste is good, but if you made a mistake and you copied and pasted it everywhere, that's not good. And now we can compile. And you see here we get those structs, normal, those fields, home delivery, udon service, golden mic service, and here we got the thread used. Provide service, golden mic is available. Private room karaoke here is available for VIP. Client for free and home delivery is available for people spending more than 5,000 yen. Okay, so now you've seen the most basic way to implement thread. Now we're going to be trying to mix it with what we've learned before. Threads plus generic types. Let's make it more powerful, step by step. That's what makes this hands-on part long, but it worth it. So we got our structs, we got our service. How are we going to implement now generics? Let's now use generic type. It will help prevent errors. We put the T, thread service, at the definition of it. So we got the little T here. We keep the signature, provide services, that we've done before. But now we're going to create another function, signature, which is going to be using the generic type. So this function is going to be more flexible. So let's create a function using flexible field that we're going to add to those structs. Get paid, for example. So for all those services we might be wanting to get paid, we got a ampersand self, which is going to be the struct type, the struct, and the cost. The cost is a reference to this T type. Here, T, we got the type here, and the cost is an ampersand of that, just to be able to manipulate it and play with it without altering the initial type. And here we're gonna add this field to all the structs, different fields, some using generic types, some not using generic types. Number of people is a U64. Cost is a generic type, T. That's for the karaoke. Let's go for the manga kissa. In the manga kissa, we will use the same number of people. And we're going to be saying that it's a U64. And the cost, which is a type generic T. Let's put a little comma here and here. And for the store, should we leave it like that? Let's make the store, we had a delivery service, for example. So maybe I'm going to put an address, maybe a location. Address, it's going to be just a string. And the cost, which is going to be T, generic type T. Okay, now we're done with the threats. We have implemented generic type. We have also implemented generic type into the structs. We added a field which is not a generic type and another field using the generic type, just to show you that I can mix it. And here, what I'm going to do, I'm going just to comment out what we've done before and try to reuse it by just copying and pasting and just doing those modifications. I keep track of what we've done before. Just gonna keep it in the file like that. And now I might go here just to cut the file, copy it, and go back in and paste it. Okay, now I got everything here. I'll be commenting just to explain why I'm doing those modifications. Let's close this comment from now on. Here we can say we have added fields, and the one using the generic. And one generic field. Okay. But we need to have that generic type defined at the struct level as well, because here I just did cost, the field cost using the generic type, but this won't work like that. We need also after the name of the struct. Here it says struct karaoke, struct mangakisa, struct store. We need to implement this generic type. So you do it like that. And now it's activated. So there won't be any error because of that. If there's any errors in the compiler, it might be for something else, but not that. Okay, T and T has to be in the both placement. And now we're going to do the implementations with generic. So that was the copy and paste. We have pasted everything. So at impl, you need to put the T. At service, we need also to put the T because it's implementing the generic type at this level also. So this is mangakisa. I have another one just before that. Just comment before doing anything. With types, chosen and written by us. Okay, implementation with generic, which is a little bit more strict. So here what I'm going to do in this first kind of example of using generic types is to determine the type. So it's going to be kind of strict, still more flexible. Than the example before this one. So we're going to go step by step, because at the end of the video you'll understand that the last example or the second last, if I had used it straight away, it would be just too hard. So here service, we're going to say it's a U64. Karaoke is also a U64. Maybe define it like that. We keep our first implementation, provide service. This one won't change. And here we got the get paid signature that we're going to use in order to get paid in this karaoke. And the cost is an ampersand of the type U64. So that's our T. So in the implementation, what we're doing something specific to karaoke by choosing the type. While in the struct and in the thread, we just kept the T to have this freedom of doing it at the implementation level. Okay. So now we're going to create a variable. We're going to make some operations. Let total cost per person is cost divided by self number of people. And now we're going to be formatting a message. Let total. We use the format macro. We're going to return total. And here we're going to put our string literal and use the variable as a placeholder to format this. Okay. Total cost per person will be, this will be the result, and I'm just going to copy it and do the same for the other implementations. We get paid here also. The service is the service Mangakisa this time. The function won't change a lot. Implementation with the signature get paid. Still ampersand self, which is the struct, and the cost an ampersand U64. So let's do the similar modifications by here changing the type, showing how flexible it is to have this T defined, when before it was U64. Here we're going to use an float, an F64. Here, cost is an F64. Okay. But yes, it's a bit tricky here, but number of people is a U64. You remember in the struct, that's what we have defined. So we cast it, we convert it. We need to convert this U64 to an F64. They need to be same type. If we want to do the operation, division, for example, here. We're going to use the as, so number of people, as, so it's a U64 and we're converting it to a F64 using as F64. This is called casting, converting, has been converted, so now cost will be able to divide it by self number of people. So those conversions using as, you can do it like that when it's two integers, but if it was an integer, you can't convert it to a boolean or to a string. You can't use as like that. It has to be same kind of same type. So now we are in the store implementation. I'm going to do those modifications. Here we're going to say U32. Just to have three different types. for those get paid implementation, so that you understand that you can change it. Here there won't be any operation, no addition, multiplication, subtraction, nothing like that, or division. We are just going to return the cost. Will be delivered to. Okay. Total cost is, and we say yen, and will be delivered to, we put cost, and we put self address. So here you remember we said the address for the store, so we will be able to deliver that person. We're just going to adapt those instantiations by adding those new fields. In karaoke we have number of people. We're going to choose a number. It's a U64. That's the way you can write also numbers with their type. So here 4 people, and we say it's a U64. The cost 8,973. We say it's a float 64. Number of people. So I'm going to use that example for the Mongo Kisa. I'm going to change the karaoke one after, because the F64 was in Mongo Kisa. Here we're going to just change. This is a U64. We're going to put the cost at 12,000 yen, 12,300, and 7 people. And after, for the store, we need an address and we need the cost. For the address, we're going to create a string. We're going to create this address in one neighbor of Tokyo, which is 327 Komazawa Daigaku Setagaya, Tokyo. It's a random address for the 327. I don't know if it is really a real address, but for Komazawa Daigaku Setagaya, Tokyo, this is real. This exists. Cost. We need to add a cost to this store item, which is going to be delivered. So the cost is 7,900. It's a U32. Okay, we have those different types. F64. F64. So they're all matching here, the types U32, F64, and U64. So now the last step, after having done this instantiation, having added those fields, we need to call that method getPaid, and we need to add the variable in it also. This one takes a parameter, which is the ampersand, for example here, karaoke 109, distanciation that we have created, reference.cost. So we need the cost to be passed as a parameter. Let's copy this, and we do the same job here. We're gonna call get paid and instantiate. What was the name again? Manga Kisa 109, and the cost. Get paid percent Junko Store 109 dot cost. So that's the store and the cost. And here we got the total. Let's run and see if we got some errors. Yes, so there are some missing semicolons. Here I put yen. I didn't put maybe the variable. So comma with variable name, implement service for store, expected one generic argument, which is this one here. So, okay, I forgot the T for the store. I didn't put the T. I didn't put the type. So U32. Here I have U64 and karaoke U64. Here I have F64 and F64. And here at service, there is nothing. So let's put this. It was U32. And here also U32. So this is one error fixed. Missing semicolons. So I did several prints. Yeah, I'm missing the semicolons here. So let's put a semicolon here. For the other ones, we're okay. I clear this. I run it again just to see those other errors. Total cost per person. Unused variable. So I need to use it. I need to return it. At least. Just gonna try to spot it. VIP, we return VIP client. Total cost per person. Yeah, this was one of the errors. We did the format, but we didn't format anything. We need to put it here. So it's gonna go inside the string. Literal. This is good. We might have less errors now. VIP client service. Let's take the self-service. Okay, this one I didn't miss it. Total cost per person. Here also. And we put it. Okay. Self-address and cost. This one is fine. Let's try again. Should be okay. Yes. So you see, using the T didn't change anything. We got it printed as before, but now we got those number of people on cost. For the struct print, we still got our golden mic available for private rooms. Total cost per person will be 1,000 after there's the calculation done for each of those. So everything is working fine. And here we got the delivery at Komazawa Daigaku. Okay, so you've seen the first level of generic types. When you, on the thread and on the struct, you use a T. And then now let's say thread generic type T, any type. Because here we were choosing the type at the implementation level. Now let's, at the implementation level, not put any type. Just use the general T. It's almost the same, but there will be a little bit more to do. I'm just going to copy this because I'm going to comment out what we've done before and do those new implementations. So here you've seen the thread changing in the example before. You've seen the struct changing because I added those T's. For the implementation, there were a minor change. Just added those types. And here we are going to implement the type fully generic at the implementation level also. So for the field cost, of each struct to be whatever type okay. So instead of, for example, what I've used before, U64 or using F64, U32, okay? Instead of using those three, as we've been using those to show that it takes any type, we can use the same signature. I'm going to paste what we've done before, and we're going to be modifying. Just get rid of the comments. So here, we had here U64. Now we got a T. Karaoke, we put a T also here instead. Okay. So the T that we got here now is going to be generalized to the implementation also. %T, T for the service trait. We're repeating ourselves, but it's fine. we need to understand what we are doing because it's going to get a bit more complicated. So as we've done at the struct and in the threat level, in the implementation level also we need to put this T. So here we will also to add the generic type T. Okay. So the impel keyword will also hold that T type. Here we will need also to mark generic type with a T and the impel keyword level also. Impel T. And now we will need to add a keyword that we haven't seen yet. I never used it before as well. So I've been learning about this specific case and that we need to use it this way. So there's a keyword here where we say the T and we implement display for the T. So here you can do your implementation. So display will be implemented for the T. So we won't need anymore the debug mode. And this one here is the most important one, plus div. So because we're doing some calculations, some operations, we need this div u64. And the output is going to be back to a T type. So while we're doing any operation on T, that's what the div means. Please cast it to a u64, convert it to u64, and after output the T type. Whatever the result is, it's going to be of type T. Okay, so this is for the beginning of it. Now, this function here is going to be a bit altered. We're going to change it a bit. Here we don't get 64, we get %T. The cost, we're gonna dereference. To get the value, because we're doing a division from the type T, which is gonna be here. So the div means division, so division u64, so we're gonna get the value as a u64. For generic type, we will need to get the value using the magic star. So we're doing that because it's generic types. For generic types, if you want to make some operations, plus, minus, divide, multiply, there are some specific stuff to do. Okay. And here we implement display. So no need comma, question mark anymore. comma question mark, we can get rid of it now. Here, we can get rid of it here, because we're implementing display, so all good. It's going to be printing. Also, to be able to make operations plus, multiply, minus, or even divide with generic types, we need div. Here we're doing a division, so we're going to use div. Use 64. Here div will convert it while doing the operation to a U64 type. Okay, and the output after calculation, the type T. So we're going to come back with it. It was T before, it's T after. The type won't change. Only will be the type altered during the operation. And we need, because it's a generic type, reference of it. To do this operation, we need to use the star. We did that before, doing some operations on the references. We use the star, so just to see the star, here is the same when we're doing an operation. We need to import display and div. So here we're using it, but we didn't import it yet. So we just go at the top of the page, somewhere here. I'm just gonna, so from standard library, formatting, FMT, display, and the other one, where was it? From standard library also, I think is OPS div operations, and this operation is a division. Need to import those two for implementations. Okay, we did import, we did modify the implementation. Now using a generic type, there's a little bit more to write. We use the keyword where. First, at the impl level, we put the T. The service on the karaoke also, there is the T. Okay. So same as here, karaoke, the cost is a T. After that, we use the keyword where. For T, now for this T here, we're going to be implementing display, implementing div, which is going to be a U64 during the division, so T is going to be converted to that, and output back as a T, how it was initially, with the result. Okay, that's how I see it. Makes it easy in my mind to understand it. It looks complicated, but that's the story. And here we use references of the struct and the type. We use the star to make the operation and get the value to be able to divide it. Okay. To do this division, use 64. while doing the division on the self number of people. Here is also U64. So let me just show the comments before closing it. Number of people is of type U64 as well. Therefore, we can perform the operation. Okay, they both have a U64 type. And after we do the formatting, we have implemented display, so we don't need any more. You see here display, so we don't need any more the comma, question mark. So you got the explanation. We did it for one implementation. Now we're just gonna repeat the same process for the other ones. So here's gonna be a T. We get rid of the F64, we put a T in Mangakisa. We put a T here also. This one also is a bit tricky because it's an F64 and self number of people is a U64. So T, we implement display, we implement div as we did before. But here we want an F64 to match the number of people type. Output T. After here %T instead of %F64, we use the start for cost. Okay, and for here, so here number of people is a U64, but we cast it as a F64. So we already converting it here. So we got two numbers which are F64 that can be now divided. So here cost will be an F64, as you can see here. Because this of type %T, we use the start, and the %T has been an %F64. We use the start, it becomes an F64, and the number of people is converted to a F64 using the as keyword. Okay, it's casted. It was initially a U64 as we have defined it in the struct. Using as, okay, as F64. That's how we convert number of people to an F64, while it was a U64 initially. Therefore, operation can be performed. Now you got it. Let's close these comments. So for the store, we're gonna always be gonna be lighter, not that heavy. Just gonna leave it a bit simple, but doing the same implementations at his level. So we don't use anymore the U32. Okay, the cost here. So here we're not doing any operation. So we don't need to use where. We don't use to need to use the div that we have used before. Okay. think we're good. Just going over it again. Okay, let's clear this. Let's do a cargo run to see what's wrong first. Implement T. So here it's saying that we need to clone. So yes, there's something missing. We need to use copy. I forgot the copy. So here we implement display and also copy. So this is like cloning the variable t to be able to play with it and do those operations. So it's better to go to the terminal and see that error happening so that you can see that you have to do it, or you go to the documentation and you read the book if you like to read the book. So here in the store I omitted the where because I just told to myself there is no operation happening, but we need to implement display and copy especially. I need to implement. I do the div u32 for example, output t. I'm just gonna mimic what we've done before. So if I need to do any operations, everything is implemented already. Let's try a cargo run again. Okay, T. Okay, here there's a typo. It's not a lowercase t, it's a capital. Let's go and change this t. Where is it here? Let's put it back to normal. I might just leave it like that, not do any calculations. For the store, where T as F. So here I'm at the bottom of the error. Let's go to the top. Help, there is an associated type with similar. I put output instead of output. So we're missing a T here. It's not going to work. For the moment, we're doing some errors. They're more at the typo level errors. So you have to be careful with that. Okay. Cargo run. Yes. So you see we have implemented the type, the generic type at the implementation level. So now the whole code, thread, struct, and implementations are having those ones. So when you're doing your instantiation, you can use any types. It's still a bit strict, because you see let's see, thread generic types, two different generic types. There'll be more complexity. How do we do that? So here we will be adding an extra generic type different from the type T, because we have different fields in our struct. We're going to transform one of those fields into a generic type. And what we're going to do, we're going to make operations between those two. So just try to think what is going to change in the code. It's going to change in the code the struct, because we're going to change the type for a generic one. It's going to change in the code the implementations, because we need to add this new type in the implementation definition. I'm just going to do the same process, copy and paste what we've done before. Okay. Let's close this. And now we're going to do our changes. So, as expected, we're going to be working at the struct level first. Now, let's push it to superpowers of traits plus generics. Generic types. So the number of people here, I'm going to change it from U64 and use those generic type. So the new type that we're going to use is going to be called N. And the U64 is going to disappear. Let's start here with karaoke first. N, and the U64 is going to be of type N. We do the same here. We leave the store alone. So to not add the complexity, we're just going to do it with the two structs, karaoke and the manga kisa. While the store is just going to be staying the same as it is. Because what is interesting in karaoke and manga kisa is that we're doing some calculations, some operations. So you'll be able to see a well-rounded example, having it implemented. So in the implementation here of karaoke, what is going to change in this implementation? As expected here, we're going to add the new type implementation level. At the service level, here we're not going to add N, but at the karaoke, yes, because it exists, it's defined in it, we're using it. So we have just T in the trait defined definition. So service is the trait definition. We could use N in the trait definition, but we're just gonna leave it as it is, with its signature. While in karaoke, which is the struct, at the struct level, we have T and N defined as generic types. So the implementation is also using those types because it's the implementation for karaoke. So TN karaoke, and impl keyword use also TN. Okay. Therefore, we indicate both for the implementation impl So T, implementing display, implementing copy for the cloning. Div, division, U64. So here we don't want U64 anymore. We want to add more flexibility. We want it to be of type N. Same type as the number of people. And to output back type T. So we use to convert to cast the number of people, which is of type N. So in our operations, as we have changing in the struct number of people for type N, we need T type to be able to do this division to be also of N type. So it's going to take whatever type we've used for a number. Type here, it has generic N type, therefore we just replace it here with its generic type. So that's why I did it step by step, for you to understand why those letters are placed where, so that you can see what it was before. It was working also before. Sometimes it doesn't work after. But after those changes, you see it evolve step by step. That's why the example part is a bit long, but it's very useful to just build an understanding of how it works and why do we need to use that and why do we believe that it's more powerful like that. Here, nothing changes. Because we got our T type already. We got the star, we got the value, self, maybe the casting, number of people, output T. I will see at the compiler if the compiler tells me to change it. Implement display, so we can display total cost. So here, the start cost will be casted to type N. Okay, just for the operation versus another N, which is self number. The self number now it's of type N. Number of people. Then output will be T. Back to the T type for the result of total cost per person. Okay, total cost per person will be of type T. So whatever T is at that moment, it will be of type T, which already there the impl implements display. Okay, as it implements display, we don't need the formatting. So we're not changing much the function, just change the definition of the implementation. And we add more comments. So we're gonna mimic the same process for Manga Kisa. we do the same for manga kisa. So you tell me what we're gonna do. Implementation TN. Manga kisa TN. Service T only. Display, copy, divide. We want to divide by a type n because number of people is of type n. Okay. So that's all the changes that you need to make. The start at cost stayed the same. Maybe we can, what can we say in the comments? We comment here instead, but here, because it is a F64, it is a bit tricky. Because here we're going to use the float number. So what we're going to do here, that's the tricky stuff. We're going to use divide. T is going to still be a T type. Okay, just going to place it like that. And here we're going to say from F64. So it's going to be converted to an F64. For the n type, we are going also use it in the where statement, where n is implementing also copy. So the from, that's how you use it, from, and you put the type F64 and the n into U64. So we put the n as into U64 because after we are going to cast it, to convert it. We're going to use as F64, so it's going to be converted to an F64. We will be able to do the division T by n. So here, the n will be U64 that we will be able to cast, okay, to convert during the operation to an F64 easily, just like that. Okay. I don't know if it is easy, but that's how we're going to do it. And here, let's comment about the T. So for T, we will have F64. So the T type during the operation of a division, it's going to be an F64. So this is how you can see we use thread, and the implementations, they're all a bit different. They all have their own little implementations. Okay, and we need here just to remind you that generic types, operations, plus minus, multiply, divided, need more work than normal types. I mean default types. So here we need a bit more work for that. It's not that easy. Need to do it, play with it, have some errors on the compiler, read the errors, because the compiler is also like the book. It's going to teach you some stuff. You can't follow everything it tells you, but fixing the errors step by step will help you to understand the logic of your code and how to perform it in Rust coming from Python. So the recap: number of people is of type n. Okay, that's the type now that we have defined in the struct. Here, because we're using a float 64, we're going to convert it. We're going to say whatever it is, we convert it to a U64 first. Then we're going to cast it to, then we convert T to be able to divide. Okay. So let number people has T. Okay, is of type T. We create a variable here, and now we can use the from, T from, just to put the indentation. Here is the right indentation. So self number of people into as F64. Okay. So here the into is just gonna, like in the iterations, we're gonna move the ownership and cast it. Let's close those comments to be able to do the recap easily. We need to integrate this new variable, number of people has T, to the calculation. Now the calculation becomes just get rid of this here, because we got the variable already now. Number of people has T is of type T. Inside we use a number of people here. We use into, so we move the ownership, we convert it. So it is of type, the T is T, but T F64, and the cost is an F64. So, number of people, F64. Cost, with the little start, is here. Of type T is an F64 also now. Okay, %T. That's where we use the start to get the value. Number of people is an N. We copy it into U64. U64, we convert it to an F64. Okay, that's how I understood it. You can use the comment section to teach or to talk about what you think about it. You can see if we change this after to an F64. So I was just telling to myself, why do I need to change to U64? Why I don't just use this line here? I'm gonna put the line, comment it out, and after the successful run, we will be using this one. So F64 here instead. So that's what I would be using my own logic, using just an F64 here. And here, I would just tell to myself, I don't need to convert the number to a T-type. And after inside, use into, convert it to an F64. I will just use total cost per person, use the star on cost, and here use number of people, and that's it, because it's already an F64. I can cast it, but I don't need to cast it, because it's already an F64. I have defined it up there. So that's what I would do, following my own logic. I comment it away. We got our code. We're gonna run it, check the errors until it works. And after, we're gonna see why we need to do all those stuff in order for it to work. Because my own logic, that's what I did initially, it didn't work. We're not gonna change store implementation. Store implementation is gonna stay the same. We're gonna focus on the two other ones and see what's gonna happen. Karaoke and Mangakisa. Let's clear this. Cargo run. Forgot to close some comments. Right. So there's one comment taking the full screen of errors. Here, 1 and 2 comments. Is there any other? Okay, here. Oh yes, there's a bunch of comments. So that's not 1 and 2 comment taking the full screen. That's just there, just because there are a lot of those closed. Okay, we got them, those comments cleared away. Let's cargo run this. Okay, consider constraining this type. This parameter clone. Move occurs because self number of people has type n, which does not implement copy. So we need to, you see this error, and you understand why I'm using copy everywhere. So if n implemented clone, you could clone the value. So for generic types, we need to clone the value. That's why we implemented the copy thread. Otherwise, you get this error written to the terminal. So that's just how Rust works. So just follow the instructions and we need to add this little copy on the side. So let's scroll down. Down. Now we're here. This is implementing copy. So this is fine for karaoke. But I need maybe to do it for N. Now we have an N. I didn't implement it. So CPPY. So now you understand why we need copy. As the compiler told us to clone N. For example, so that's the example which was written in it. So we were not using clone, we just use the copy. I have another N here. Here we got copy, and here we got copy also. All good. Let's clear this and see if it is okay. Yes. So you see it works as expected. We got the same results. We could have changed the instantiations, but I don't want the example to last too long, so that's why I'm focusing only on what needs to be changed. So that's how you do your implementations of several generic types. Seeing one is nice, but seeing if you have several fields with generic types. So now let's see what would have happened if we had the N as a F64. So as I told you, I have commented out those lines that that's the end of the example. So hang on if you're still watching. We comment this out into U64, we put into F64. Here we don't need this variable. We don't need to do this T conversion. That was my initial logic around that. Okay, so we close that. Here, this line also, we don't need it, because I believe that we could just use it like that, because we have already converted number of people to F64. So see here, we expect number of people to be of type F64. Okay, and the cost that we are passing through the instantiation is an F64 already. So we expect it to be able to perform the operation. Okay, versus cost, I mean star cost, so the value of it. Casted F64, right? So that's what we pass in the instantiation. That's how we have defined it here using the from F64 in the display. Cost T, we get the value. Let's close those comments. And let's see what the terminal is going to be showing us. Cargo run. Unsatisfied thread bond. Okay, number of people, value. I forgot. What did I forget? Little self. Okay, So this is self number of people, otherwise it's not going to work for sure. Let's run it again and see the real error without the typo and the logic ones. Let's clear. I'll run it again because don't see what was. Okay, now we can see found type parameter, expected type parameter, expected type parameter T, found type parameter N. You see? So the types won't change. They stay T and N. That's why we need to change the N type to a T type. That's why we needed to do this conversion. Because the same for the multiplication, addition, subtraction, and division, you need both sides of the calculation to be same type. Here we're using abstraction types, generic types. We call them T and N. So at this time, you need to do those conversions. So maybe into F64 could have worked, but I need to convert it anyway into a T type. Therefore, we can understand that the operation can be done on generic type only, and if only those are of the same type. And here it's T that we're using as a common type. Okay. Here, for example, using T as common type. That's why we convert it to a T type. That's why we convert the N to a T type to be able to perform this calculation. So this is a way of casting N for T. So converting N to a T type. Okay, that's why what I commented out here, this is not going to work. Let's close this. And let's open what we got before. This here. And that's a comment. Let's put it back to a comment. Okay, so number of people, T and T from. And after we just do it like that. Okay. So that's the mandatory one, is to do this conversion to a T type. After up there, I believe U64, F64 would just change what is inside this T type from. Just put it back as it was, if it works. There might be some different typos. And I forgot closing curly brace, that's what I've seen in the error. Let me just check those comments. This one here. Okay, we need to close all the comments. Let's close the comments. Okay, everything is fine now. Congratulations for the people who made it to the end of this video. So, as you've seen, we have seen the code evolve. And we use the example step by step to move to the frontier of what I know about it. And I'm still learning about it. So let's just conclude here saying by, okay, this was a little bit hard. I can say now it's a bit hard. Go back and check those points. But you have got I mean, you know now, you have an idea of threat and the power of using generic types with it. Use ChatGPT to explain and get more examples. Here, for example, I never used where statement. I don't know what was this, and if you could use it. I didn't went through the book for that. I just went to ChatGPT. Statement, so the where statement before in Rust, but I got it from ChatGPT. And the explanation was very appealing. So I understood what I was doing. Okay, or you can just read the book. Okay. We have seen Rust threat, a common interface that can be implemented by other types, helping to ensure type checking at compile time and making the code more reusable, and at the same time more specific, which with each implementation needed, as it is a type signature like interface. If you have made it this far and followed along from the beginning of this playlist, congratulations. You can already start coding some stuff, but there are still some few topics to complete the Rust workaround. I highly encourage you to continue and start playing with it. Use ChatGPT as well, as now you are able to understand and read the code and suggest your own modifications and implementations. We are going to stop here. Hope that you liked this video. Thanks for your support again. Please like and subscribe, and see you next time for another Have a Break, Have a Rest session.